Now we will discuss about the chemical properties of the metals. Metals, when reacts with oxygen, it forms corresponding oxides. Can see here copper combines with oxygen to form copper oxide. Aluminium combines with oxygen to form aluminium oxide. Generally, oxides of metal are basic in nature. But certain compounds like zinc oxide and aluminium oxide shows both the properties of acidic and basic behavior. So those compounds are called amphoteric oxides. Amphoteric oxide. So aluminium oxide combines with hydrochloric acid to form aluminium chloride and water. The same time aluminium oxide is combined with an alkali to form sodium aluminate. Now let us discuss about what happens when this metals reacts with water. Once a metal reacts with water, the gas, hydrogen gas, is evolved when metal reacts with water. Now let us discuss about the metal, how does it reacts with water. For example, sodium metal, when combines with water, it gives sodium hydroxide and hydrogen gas. Sodium hydroxide and hydrogen gas. Similarly, potassium when reacts with water to give potassium hydroxide and hydrogen gas. In order to balance the equation, have to put here 2 each for balancing on both the sides. So this is how this sodium combines with water and potassium combines with water to form corresponding hydroxide and hydrogen gas. Now certain metals like sodium and potassium, they are highly reactive, and even when it is exposed to air itself, it combines with oxygen and catches fire and explosion takes place. So it is kept under kerosene. That is why in laboratory sodium and potassium metals are kept under kerosene, because when it is exposed to air it catches fire. Now let us discuss what happens when it reacts with dilute acids. So normally dilute acid, when it reacts, the metals, when it reacts with dilute acid, it also displaces hydrogen gas. But dilute nitric acid is a strong oxidizing agent. It will not displaces hydrogen gas. So it itself converts hydrogen, oxidizes to hydrogen to water, and itself gets reduced to oxides of nitrogen. So these are the chemical properties of metals. Now let us discuss about reactivity series. Displacement reaction we have already discussed. Reactivity series is given in the textbook. So according to the reactivity series, page 45, sodium for potassium is the highest reactivity metal. Maximum reactivity is for potassium, and least reactive metal is gold. So according to that, reactivity series is given in the textbook. Now let us discuss about how this ionic compounds are formed, how metals reacts with non-metals. So let us discuss about that, how metals reacts with non-metals. We can take an example, sodium chloride, for how this metals reacts with non-metals. So sodium chloride is NaCl. How this compound is formed? Atomic number of sodium is 11 and chlorine is 17. Its electronic configuration of sodium is 2, 8, 7 and 2, 8, 1 and chlorine is 2, 8, 7. This is electronic configuration of sodium and chlorine. Now let us see. Here one electron is present in the outermost orbit of sodium and one electron is deficient in outermost orbit of chlorine. In order to form stable configuration, sodium will lose one electron and it gives one electron to chlorine and chlorine will accept that electron. So that electronic configuration of sodium will become 2, 8 and chlorine it becomes 2, 8, 8. So sodium gets converted into sodium ions Na plus and chlorine becomes Cl minus ion. Now in this case one electron from sodium is given to chlorine so that chlorine has become 8. It's a stable configuration. So in this case you can see sodium atom, that is it's one electron, it is giving to this chlorine. Chlorine is having almost 7 electrons in its outermost orbit. 7 electrons are present in the outermost orbit of chlorine. And sodium is giving this electron to chlorine so that this compound is becoming NaCl by transfer of one electron from sodium to chlorine and chlorine is accepting that electron. Such type of bonding which is called ionic bond. Now let us discuss about another example, that is magnesium chloride. Now how this magnesium chloride bonding takes place in magnesium chloride. We will discuss magnesium chloride. Magnesium chloride is MgCl2. Magnesium chloride is MgCl2. Here the atomic number of magnesium. We will discuss the second example, that is magnesium chloride. Now let us discuss how magnesium chloride is formed. Magnesium atomic number is 12 and chlorine atomic number is 17. Its electronic configuration of magnesium is 2, 8, 2 and chlorine is 2, 8, 7. Here magnesium 2 electron is excess for magnesium in order to become a stable configuration and 1 electron deficient for chlorine to become stable configuration. A 2 chlorine atom is there, so one magnesium will give this electrons to 2 chlorine atom, that is 2, 8, 7. So magnesium can give 1 electron to this chlorine and 1 electron to this chlorine so that it becomes a stable configuration. Now let us see how it forms. So magnesium Mg is having 2 electrons excess and here chlorine Cl, chlorine atom is having 7 electron in its outermost orbit. Here another chlorine is having again 7 electron in its outermost orbit. Now magnesium will give 1 electron to this chlorine and another electron to this chlorine so that 8 electrons are there for chlorine and magnesium is having 2, 8 configuration. Here the electronic configuration after losing it becomes 2, 8 and this becomes 2, 8, 8. Here also 2,